All right, so number one. What is our first thought here? In order to subtract two rationals, we must have a what? Common denominator. Okay, how do I get a common denominator? Good, okay. So here, whoa. So here, does b minus 7 and b minus 1 have a common factor between them? No. So to create a common denominator here, you basically need to multiply each of the rationals by the other's denominator. So we're multiplying this rational by b minus 1, and this one by b minus 7, b minus 7. Okay. So now, our first rational is over, b minus 1, b minus 7, as well as our second rational, b minus 1, b minus 7. Now, should I leave this as 3b times b minus 1? No, right? Because I know that my goal here is to combine the numerator. In order to combine the numerator, I need the tops to be in standard form. So I do need to multiply or distribute 3b. So we do 3b times, oh my gosh, what is going on? 3b times b and 3b times negative 1. So 3b times b is 3b squared, and 3b times negative 1 is negative 3b. Same thing over here, we have to distribute the 6 to the b and the negative 7. So we end up with, yes, 6b minus 42. Now what do you think is tricky about what we now do while combining? What is tricky in this problem? So we have a negative between. Now I've been seeing a lot of people doing this in various ways. Unfortunately, so I've been seeing a lot of this. Distribute the negative, and then they write this. So they did distribute the negative, but what did they do improperly? So once I distribute the negative to both the 6b and the 42, what remains in the center between our two rationals? A positive. Okay? That's why I normally don't show it. I don't write down the distribution. What I normally do is I just make sure I draw these arrows to remind me that when I am combining these, I must subtract both 6b and negative 42. So I kind of like combine two steps in one here. So 3b squared, is there anything to combine it with in the second rational? Are there any like terms in the second rational for 3b squared? 3b squared, is there a square in the second rational? No, right? So it just remains 3b squared. Then we have negative 3b. Is there something to combine it with in the second rational? The 6b, right? But remember, it's negative 3b minus 6b. Negative 9b. Then there is no constant in the first rational, so it's just minus negative 42 plus 42. Okay? Then it's over b minus 1, b minus 7. So now I need to try to factor this top. What do I do first? You pull out a 3. You look for a GCF to pull out, right? So you pull a 3 out, and you're left with? Good. Then you ask yourself what about this numerator? What do you ask?
What times what is 14 but?
Yes, perfect. What times what is 14 but adds to get negative 3? Does anything multiply to get 14 but add to get negative 3? No. So guess what? It doesn't factor. That's okay. We put this problem in the warm-up on purpose because sometimes you are going to get polynomials that don't factor, and it's okay. It's okay. This can't be simplified anymore. This can't be reduced. So this is our answer. This is in its most simplistic form right here.
So would we just have the answer be the starting thing?
This is it. No, this is it.
Oh.
This is our answer. Right here. On your quiz, you may have a problem that does not factor, just like this. Yes?
This is kind of a weird question. Can we use the variable b on the test at all? I get them mixed up.
I don't know. I do not believe that there is a B. Yes, Chris, you have a question? Okay, so are we solving for x here?
No.
No. We're not solving, we're just simplifying. So, no, we do not have to use the quadratic formula because you use the quadratic formula when it asks you to solve. So what we're learning today, solving rationals, yes, you may have to use quadratic formula, yes. Okay, so now number 2, let's just go over it. I'm trying to do what here? What is my first step? Again, get a common denominator. Okay, so does p minus 2 and 6 have a common factor? Nope. So again, it's just like the previous one where I have to multiply each side by the opposite's denominator. So this will be multiplied by p minus 2, and this is 6 and 6. So our denominator is now 6 p minus 2, and should I leave the numerator on this left rational as 6 times 2p?
No.
What should I do? Combine here, multiply. So 6 times 2 is 12p. And then same thing on the right, I should distribute the 8p. So 8p times p is 8p squared, and 8p times negative 2 is negative 16p. Is there a negative we have to worry about in the center? No, so this is very straightforward. We just do 12 plus 8p squared minus 16p, which is what? 8p squared minus 14p. Perfect. Woo. Yeah, 14. What did I do there? 4p. Thank you. Now, what do I need to do next? Factor the numerator to make sure there isn't something I can cancel out, right? So what can I factor out of 8p squared minus 4p? I can take a 4p out. Good. And I'm left with? Now, is this my answer? What can be reduced here? Does 4 and 6 have a common factor? Yes, they have 2. So, what is 4 taking out a 2? What am I left with? 2. And 6 divided by 2 is? So my answer is actually 2p times 2p minus 1 over 3 times p minus 2. Those of you that did turn it in, you see how close you were? You just forgot this step right here. Are there any questions about number 2? Does this clear things up a little bit? Make it a little more straightforward?
Yes.
Okay. Yeah. So just remember, your goal, get a common denominator, right? Combine the numerator. Watch out for the negative in the numerator, right? And then factor the numerator, and you're done. Yes?
So when you're multiplying 6 times 2p minus 2, do you always just like put them together? Like what if they have a common number? Do you always just put 6?
Like here?
Yeah.
I want to leave the denominator in factored form in case when we're way down here, I may have two factors that cancel.
Okay.
I don't actually want to combine the 6 and the p minus 2 because then I wouldn't be able to see, oh, I have factors that can cancel. Okay? Good.